All right, so assignment number 12 is the last assignment in Unit 7, and we're going to be factoring still. We've factored the greatest common factor already, and we've factored quadratic trinomials into two binomials with the parentheses. And so here we're going to have some special cases. We're going to be factoring what are called perfect cubes, and the difference of, should be difference of squares there, difference of squares. And perfect squares, it should be. So let's go ahead and get started with this. Number one, let's go back to what we've done in the past, and let's go back to multiplying. If you remember, we called these two conjugates because of the same factors, just different signs. So, and then here we're squaring a binomial. So I'm going to have you pause the video, try to do those on your own, make sure you remember how to do those, and then start the video back up. Hopefully you've done that, and let's go ahead and work through this. 3x times 3x is 9x squared. Then I'm going to take 3x times positive 5, which is 15x. Then I'm going to distribute the negative 5 out. Negative 5 times 3x is negative 15x. And then negative 5 times negative 5 is negative 25. So when I combine like terms, I have my 9x squared, and the positive 15x and negative 15x, those cancel each other out. So then I have minus the 25, and you can see that what happens here is that the middle terms cancel each other out, and I don't have a middle term in my answer. It's just 9x squared minus 25. Well, this problem right here, this is called the difference of two squares. This is a perfect squared because if I square 3, I get 9. If I square x, I get x squared. This is a perfect square because if I square 5, I get 25. And so it's the difference of two squares. And what we're going to be doing today is talking about how to go backwards to get an answer of 3x plus 5 times 3x minus 5 if we were to factor the difference of two squares. Let's take a look at number 2. I'm squaring this, and we have to remember that when we square a binomial, it means that we're going to take the binomial, which in this case is 2x plus 7, and multiply it times itself, which is 2x plus 7. So I'm going to FOIL this. 2x times 2x gives me the 4x squared. 2x times 7 is 14x. 7 times 2x is another 14x. And then 7 times 7 is a positive 49. And then this simplifies to 4x squared is my x squared term. I have 14x plus 14x, which is 28x. And I have the plus 49. Now, this is what we call a perfect square trinomial. And it's a perfect square trinomial because if we were to factor it, we would get two factors that would look like this, 2x plus 7 times 2x plus 7. Since those are the same thing, we'd have a 2x plus 7 here and a 2x plus 7 here. And since those are the same thing, we could write it as 2x plus 7 squared. And so what we're going to be doing today is starting with what's in the boxes and talking about how to factor those. Let's go ahead and get started with number 3. So we're going to factor 9x squared minus 30x plus 25. And so there isn't a perfect square that goes, or a greatest common factor. So what we're going to do is try to pull out something here and here that multiplies together to give us 9x squared. And in this case, it is 3x. I wrote a 2. It is 3x times 3x. Now, if that didn't work, we could come back later on and try 9x and 1x, but I know 3x times 3x is going to work in this situation. We can also try something here and here that multiplies together to give us the last term, which is 25, and that's going to be 5 and 5. And so I'm going to put a negative sign here for both signs because a negative 5 times a negative 5 is still a positive 25, but I need them to add up to a negative 30. So I'm going to try my inside terms. Negative 5 times 3x is negative 15x. 3x times negative 5 is another negative 15x. Those two add up to a negative 30x. And so my factors are the same factors, 3x minus 5 and 3x minus 5. And what I would like for us to do when we get two factors that are the same is to simply write it as 3x minus 5, one factor squared, instead of saying that we're multiplying it by itself. So this is our answer for number 3. I'm going to try to factor number 4. What you notice different about number 4 is that it doesn't have a middle term, but we can still factor it. The same way we factored all of the other binomials or quadratics. I'm going to start by trying to figure out what times what gives me 16x squared. And that's a 4x times a 4x. Gives me 16x squared. Then I want something here and here that multiplies together to give me negative 9, but adds up to 0 because this is like 0x in the middle. And so I know that a positive 3 and a negative 3 multiply together to give me negative 9. And if I check my inside terms, this is 12x. And if I check my outside terms, that's a negative 12x. And those two things do add up to be 0. And so they would cancel each other out. And what you see here is I have two conjugates. And so my factors are just 4x plus 3 times a 4x minus 3. So this was a perfect square trinomial here because the factors are the same thing, and we can write it as something squared. We call this factoring the difference of two squares because when I factor it, I get two conjugates of each other, and I will always get two conjugates if I have a perfect square here minus a perfect square here. I'm going to have you pause the video and try 5 and 6 on your own, and then start the video and see if you're able to come up with the correct answers. And if you were able to do it correctly, the first one, number 5, we know that 2x times 2x gives me 4x squared. A negative 7 times a negative 7 is a positive 49. And then my middle terms, negative 7 times 2x is negative 14x. And my outside terms, 2x times negative 7 is another negative 14x, which adds up to negative 28x. So then I would write this as 2x minus 7 squared. That's a perfect square trinomial. Number 6, I know that 5x times 5x is 25x squared. I also know that negative 8 times positive 8 is negative 64. And negative 8 times 5x, my middle terms, that's a negative 40x. And if I check my outside terms, 5x times 8, that's a positive 40x. And so those factor each other out, and I get no middle term. This is what I would get if I have a difference of two squares, which is what that is, and it would factor into two conjugates, 5x plus 8 and 5x minus 8. This is what our homework is on tonight in our homework assignment, and we'll go over questions tomorrow in class. We will see you then.